We saved this to the end because this is a very special case. Sometimes we cannot separate the variables to integrate one, like both sides. Sometimes the equation is impossible to do that with, and in that case, we have a different kind of solution that's going to be a completely 100% visual solution called a slope field. It provides a visual guide to the possible solutions, but those solutions can change depending on where you are. So here's an example of just a separable one, a basic separable one. Dy dx equals x. If I separate this out, I get dy is equal to x dx. Integrate both sides, and get y is equal to x squared plus a constant. And, x squared over 2 plus a constant. And if it says subject to y of 0 equals 0, that would just mean that c would be 0, and I would get y is equal to x squared over 2. And this is occurring when c is equal to 0. So the graph of this solution is shown below, along with tangent lines to the curves at integer values, meaning just tangent lines everywhere here, 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 and you can't see the tangent lines on this graph right here. This is a graph pretty much from -4 to 4, but if I were to kind of sketch them in on top of this, I would get something that looks like that, and then that, and then that, this, and just delete the graph and you can see that's what's happening right below. One way to think about that is that this is basically showing what the graph is going to look like. I know what's weird if you think about this, when you look at this graph right here, you see the parabola, and yet all that's actually there are just straight lines. So that's essentially what a slope field is. This is a slope field particularly when c equals 0, but sometimes we're not going to know what that c is. So I'm going to show you what that slope field would look like, skipping a little bit ahead to where if c were not equal to 0. This is a whole slope field if c were not equal to 0. And if I were to, hang on just a second, there we go. Looking at this side by side, you can kind of see that in some very specific cases, if I took this parabola that is represented here, it's just kind of might be hard to see, but you've got a parabola right there, and that's for that particular c value. And as your c's increase or decrease, you're going to have the different possible parabolas that you can get based on your slope field. Don't make this harder than it has to be right now. Let's try an example of building one. On the axis below, we're going to schedule the slope field for the given differential equation for the 15 points indicated. And the differential equation we're going to use is dy dx equals x, the same one. So this is the slope field that you can see right above here. We're just going to do it at these particular spots. So what this means is that every point here, your slope is actually the same as the x value. This is basically saying slope equals x. So my slope here is, my x is 1, my slope is going to be 1. So I'm going to draw a little tick mark that has a slope of 1. Now how do I know that's a slope of 1? Well, because that's up 1 over 1. And so I'm going to go 1 and just try to draw a 45-degree angle line as best I can. It is a sketch. Here my slopes are -1. And so I'm going to draw negative 1s all on those x points that have negative 1s, and here they are 0s. And that, congratulations, is your first basic slope field. We have computers to assist us in drawing most of these, as you can see from the Graphing Calculator's version. This is an actual sub-program in the Graphing Calculator that I can give to all of you. But it's less important that you know how to do it on a graphing calculator, and just more that you can interpret them. So don't feel like you're going to be generating too many of these. You will have to generate 1 or 2 of them. What makes one possible solution different from another? That's the same as it always was. Different c values. So here's another one. Consider the differential equation given by dy dx is equal to 2x minus 3y. And we'll provide a slope field for the given equation at the 15 points. So this is going to take a little bit of time. We're going to want to generate a t-chart basically of x, y, and 2x minus 3y so I can get the slope down. Remember, this right here is the slope. So I have x values at -1, -1, -1, 0, -1, 1, -1, 2, and -1, 3. and my values for 2x minus 3y, 2 times negative 1 is negative 2, negative 2 plus 3 is 1, then I have negative 2 plus 0, or minus 0, that's 0, then I have negative 2 minus 3, it's negative 5, then I have negative 2 minus 6, is that right? Yep, negative 2 minus 6, negative 8, and negative 2 minus 9, negative 11. So let's just kind of do the best we can. I'm going to do a little break here and let's do some other ones. Let's go with the zeros because that's going to be easier. X is 0, 0, negative 1, 0, 0, 0, 1, 0, 2, 0, 3, and I have for my 2x minus 3y's I've got 3, 0, negative 3, negative 6, and negative 9. And then for my last set of points, my x equals 1, so I've got 1, negative 1, 1, 0, 1, 1, 1, 2, 1, 3. I have, let's see, 1, 3 is negative 7, 1, 2 is negative 4. Oops. I'm doing this the wrong way. I'm looking at a different chart. 1, negative 1 is 5, 1, 0 is 2, and I think it decreases by 3. Negative 1, negative 4, negative 7. Okay, that's right. So how the heck do we graph these? Well, we do the very best you can. I mean, honest to God, it's just a guess, a sketch. So right here at negative 1, negative 1, that's an easy one I can do. Negative 1, negative 1, I can put 1. Just point it straight to 0, 0. Negative 1, 0, I'm going to put 0. Negative 1, 1, negative 5. Now that is a very steep negative as it is. I just have to make sure that the next two are steeper. And then this one can pretty much almost be vertical. 0, negative 1, that's already pretty steep. It's 3. 0, 0 is 0. 0, 1 is negative 3. Oops, so that should have been positive 3, my bad. This is negative 3. Negative 6, and negative 9 is pretty much going to be almost vertical. And then 1, negative 1 is going to be positive 5, pretty vertical. 2, less vertical. Negative 1, negative 4, and negative 7, which is going to be pretty vertical. So that's a guess I can do, just guessing. I'll pause it and show you what it actually looks like. There's what the graph really looks like, and while that might look jumbled to you, it's definitely showing something. So that's essentially what you see there. Why can't you find a general solution to the differential equation above? Meaning, why can't I actually just find a solve for this? Well, if I took dy over dx equals 2x minus 3y, I can't separate the variables. You can try, but I can't separate the variables. Even if I multiply both sides by dx, I then have a dx stuck with this y. I mean, you can try algebraically, but there's no real way to do it. That's because this is subtraction, but this is division, and I can't really break that up. Okay, so shown below is the slope field for the one we had above. It's the same one we did right here that I showed you from the graph on the calculator. This is dy dx is equal to x. This is the one that was x squared over 2 plus c. So if I think about this, what this is showing is just a lot of possibilities. And on the grid above, sketch a solution curve that contains the point 2, negative 1. So we go 2, negative 1. I'm going to put a point here. According to the curve you drew, what is the value of y when, well, wait a minute, it says according to the curve you drew, and it wants me to sketch a solution curve that contains this point. Okay, so this is the tricky part. I actually am going to try to sketch a curve starting here. So I'm going to work my way up and just basically try to work my way between lines or on lines whenever I see them, and let this point me to the next spot. Just work your way very carefully. It is not a precise science, and then this is going to work down, point, curve, 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 and then as I continue, this is going to go up, 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 and basically following the guidelines. you can actually draw a pretty decent parabola by this. It's not perfect, but it's decent. And then it says, according to the curve you drew, what is the value of y when x is negative 3? When x is negative 3, I basically have like a y equals 1. I mean, that's kind of the point. So I'm going to guess negative 3 becomes positive 1. And then it says, compare this to the actual value of y when x equals 3. Well, let's see. If it contains the point 2, negative 1, I basically want to use that to figure out what my c value is. Remember, the formula was y is equal to x squared over 2 plus c. So if I go negative 1 is equal to 2 plus c, and c is equal to negative 3, then I have y is equal to x squared over 2 plus negative 3, or minus 3. And then when x equals 3, I got y is equal to 9 halves minus 3, which is 1.5. So a little off, but that's okay. I mean, if I think about this, this could easily have started curving up pretty sooner and got me to 1.5. So it's an approximation, visually. Here's another one. Consider dy dx is equal to x plus y. Since this is not a separable differential equation, we have no direct way of solving this. However, it's relatively simple for the computer, and I want to emphasize this, I'm not going to make you draw too many of those. The only thing I would ever have you do are things like this, where you just do a couple of points. For a computer to draw its slope field. So this is the program I have going on here, and I'm just going to go and redefine this g of x. Hang on, it's not reading me. Okay, there we go. I'm going to change this to x plus y, and let's view it. So this is the same thing as what we're seeing right here. Okay, and if it says, given this differential equation subject to f of 2 equals 1, that means that 2, 1 is an ordered pair. So I'm going to go right here, draw an approximate solution curve, and use your curve to approximate f of negative 2. So do your best. Don't look at me doing this. Try it on your own. Just move your way up. You want to get in between lines as much as possible, and then this is going to follow, 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 and then come right back up. Keep going that way. It looks like that's an asymptote. So if I had to guess what f of negative 2 is, I'd put it somewhere maybe in the region of 1.2. F of negative 2 might be about 1.2 or something. Okay. Then it says that this is a particular solution to this, subject to f of 2 is equal to 1. So if I want to verify that that is a solution, this goes back to old directions, so I'm going to go y prime is equal to negative 1 plus, let's do chain rule, which is just the same thing, 4e to the x plus 2. And if I want to verify that's a solution, I'm going to say that plugging this in for there, so negative 1 plus 4e to the x minus 2 equals x plus y. Y is negative x minus 1 plus 4e to the x minus 2. And I can clearly see that those are going to be equal, so check. Then it says find, or subject to f of 2 is equal to 1, so I actually want to check that y of 2 is equal to 1. So y of 2 is negative 2 minus 1 plus 4e to the 2 minus 2. That's negative 2 minus 1 plus 4, and that is equal to 1. So check. So those were the two checks from before. And then it wants me to find the exact value of f of negative 2. Well, that means basically y of negative 2. And that would be equal to positive 2 minus 1 plus 4e to the negative 4, which is the same thing as 1 plus 4 over e to the 4th. And if you plug that in, that is about 1.073. So not quite what our approximation was, but close enough. So that's it. Just kidding. I have provided this page for you, and these are just basically directions on reading a slope field. When reading a slope field, it's important to look for clues the slope segment gives us, and it's possible to read a slope field one segment at a time. However, this is exhausting and tedious for very large fields. Spot trends. Some of what you're going to be doing is trying to figure out where these things came from and what they look like. So these are some tips for you. We're going to be practicing this when I get back. But I want you guys to kind of read through these tips because this is how to take a slope field and interpret it, an actual slope field given. And these are just kind of basics on that. So I'll leave it there. Some of this stuff I want you to start to kind of realize and think about rather than just give a list set of directions. But this is there for you as you start this. Good luck.